I'm just going to do a quick video on how to calculate oxidation states for compounds. Compounds are made up of two or more different elements chemically combined, and they're neutral, which means they have no charge. So if you look at each individual element and you add them up, the oxidation state sum has to be 0. So for instance, if I have NaCl, which is salt, there's two elements here because they're separated by capital letters. So Na is sodium and Cl is chlorine. And then if we go to the periodic table and look up Na's charge, it's right here in group 1. I'm going to put a dot there. On top, the oxidation state says +1. So I know that's +1, and there's one of them, so I'm going to multiply because the subscript at the bottom tells you how many NAs we have, and when there's nothing there, it's assumed it's a 1. And then by default, in order for this to be equal to 0, chlorine has to be a -1 so that the charges cancel out, because +1, -1 is 0. And that's the first rule I want you to know, that if the last element, the element at the end, is a group 17 element, and I'll show you that here. Here's group 17. If you notice, group 17, a lot of the elements have more than one charge, and how do you know which one to use? Well, if it's at the end, and only if it's at the end, you're going to always use -1. If it's in the middle, then you're going to have to calculate it last and see what charge it is. And hydrogen prefers to be +1. So let's look at the first example. I have two elements here because they're separated by capital letters, and I know the sum is going to be 0 because it's a compound and it's neutral. And I'm going to look up calcium. So if I go right here, calcium is right here. It has a +2 charge. So I'm going to put +2, but there's one of them. So 2 + 2 one time is 2. So by default, Br has to be -2 in order to be equal to 0, but notice there's two of them, so you divide going up. So each is -1, because when we calculate the total oxidation state, you would do each Br times the subscript. There's two of them there, so each of them is -1. So if they ask what is Ca's charge, you're going to say +2. What is Br's charge? Well, each is -1. You're not going to put this down as the answer. It's only -2 because there's two of them. You would have to divide to get what each one is. And plus, I said group 17 at the end is -1, and Br is right here, number 35. Okay, next one, Al and F. I'm separating. The sum is 0. And if I look up aluminum, aluminum is right here. And the charge is +3. So if we go back, it's +3, and there's one of them, so I'm going to write 3. So in order for this to be equal to 0, this has to be -3. But there's 3 of them, so I have to divide going up. So each was a -1, and if you check, fluorine can only be -1 over here. So again, the answer would be, what's the charge of each individual element? Each Al is +3, there was only one of them, and each F is -1. That would be the answer. Here's another one. I separate by capital letters. The sum is 0. First, we're going to look up magnesium. Magnesium is right here. It's a +2. And there's one of them. So when you multiply, you get 2. So in order for this to be equal to 0, S has to be a -2. And there's only one of them. So each Mg is 2, and each S is -2. And let's check S on the periodic table. And if you notice, S could be -2, 4, or 6 when it's combined. So it is on the list. Next one. Okay, I'm going to separate each capital letter. The sum is 0. Let's look up nitrogen. Nitrogen has way too many charges, so I'm going to skip nitrogen and go right to oxygen. Oxygen is -2. So -2 for each, but there's 3 of them. So I have to say -2 3 times is -6. So this has to be plus 6 to be equal to 0, but each of them has to be plus 3 because there's 2 of them here. And don't forget, you divide when you go up. So N is plus 3 and O is negative 2. You don't put the charge of the total oxygens added up. You have when they say what is the oxidation state, it's assumed they want for each. Next one. All right, we have carbon and hydrogen. So if we go to carbon, there's too many choices. And I told you that H prefers to be plus 1. It only wants to be negative 1 when it's with a group 1 or group 2 metal. So I'm going to do H first, and I'm going to put plus 1, but there's 4 of them, so it's 4 here. So by default, carbon has to be negative 4. And since there's only one of them, you just put that on top. So carbon is negative 4, and H is plus 1. Same thing here. There's 2 elements. The sum is 0. Let's look at Fe. Fe has 2 choices, so we don't know which one to use. But oxygen is negative 2. So we're going to write negative 2 for each oxygen, but there's 3 of them. So I multiply when I go this way, and I write negative 6. So this has to be plus 6 in order for it to be equal to 0, but there's 2 of them. So each Fe is 3, and each O is negative 2. Next, here's another one. We already said O is negative 2, and there's 1 of them, so this one has to be plus 2, and there's 1 of them, so Fe is 2, and O is negative 2. Okay, next one, here's a K, a PT, and a Cl, because the lowercase letter goes with the capital letters, so the sum is 0. Now, chlorine we saw before is in group 17, and since it's at the end, we're going to put negative 1. I told you to know that. Negative 1 times 4 is negative 4. Now we're going to look at platinum, PT, platinum, and I'm trying to find platinum right here. It has 2 choices, so I'm not going to know which one to use, so I'm going to skip it. And I'm going to go to K, potassium. Potassium is right here in group 1, so it can only be, oops, I just covered it. It can only be plus 1. And so it's plus 1, but we have 2 of them, so I'm going to write plus 2 at the bottom. Now, in order for this to be equal to 0, you need another positive 2, because 2 plus 2 is 4 minus 4 is 0. And there's only 1 here, so each platinum is 2. So if we want to write this out, you're not going to write K as plus 2, because if you look on the chart, K cannot be plus 2, it can only be plus 1. So that's why when you do these, you're saying what each element is. That's why that number on top would be the answer. Plus 1 for K, plus 2 for PT, and Cl is negative 1. Here's another one. Okay, the sum is 0 because it's a compound. We're going to start with H. H is right here, and it prefers to be plus 1. So you're going to say plus 1, but there's 2 of them, so I'm going to write plus 2. Now we're going to go to sulfur. Sulfur has too many choices, so I'm going to skip it. Now I'm going to go to oxygen. Even if you remember oxygen, right here is negative 2. I'm still going to look it up. Negative 2, but there's 4 of them, so it's negative 8. So 2 plus something minus 8 is 0, so it has to be 6, because 2 and 6 is 8, minus 8 is 0. So this is a 6 because there's only 1 of them. So the answer would be H is plus 1, S is 6, and O is negative 2. Next, capital K, capital I, and then O. Now, K is right here, and oops, and it's plus 1. And there's 1 of them. I, it's in the middle, it's not at the end. Here's I. There's way too many choices, so I'm going to skip it. And then the next one is oxygen. And oxygen is right here. It's negative 2. And there's 4 of them, so I'm going to write negative 8. So in order for this to be equal to 0, I has to be a 7, because 1 and 7 is 8 minus 8 is 0. So the answer would be K is plus 1, I is plus 7, and O is negative 2. Now I'm going to do this one, separate the capital letters. Now I'm going to tell you H was plus 1 before, O was -2 just to save some time, so it's -6. So in order for this to be equal to 0, Cl has to be +5. So 1, 5, and -2 is the answer. Here's another one. We could get the H from over here. It was 1, and there's one of them. O is -2. Because sometimes you skip the one in the middle, because that's the one that has multiple charges. And then Cl has to be 7 here. Cl is 7, H is 1, and O is -2. Next. This is a good one for the test. Let's look at K. K is right here, and it's +1, but there's 2 of them, so you write 2. Let's look at Cr. Cr is right here. There's 3 choices, so I'm going to skip it. Then I'm going to look at oxygen, which you probably know already. Oxygen is right here. It's -2. But there's 7 of them, so you write -14. So in order for this to be equal to 0, this has to be 12, because 2 plus 12 is 14, -14 is 0. But they want to know each Cr, and remember, you divide when you go up. So each Cr is 6, because 6 times 2 is 12. Each K is 1, and each oxygen is -2. And on multiple choice, 12 will be an answer, and that's the wrong answer. Okay, now here, next one, carbon monoxide. Let's look at carbon. Carbon has way too many choices, so we're going to skip it. We're going to go to oxygen, which we can look right here. It's -2, and there's one of them, so carbon here is a +2, and oxygen's a -2. Now, what about carbon dioxide? Oxygen's -2, but there's 2 of them, so it's -4. So each carbon here is a +4, and each oxygen is a -2. Now, NaNO2. Okay. Let's look. Na is right here in group 1, so it's +1, and there's 1 of them. Now let's look at nitrogen. Nitrogen is right here, and it's got way too many oxidation states, so I'm going to skip it. Oxygen we know is -2, but there's 2 of them, so we're going to write -4. So in order for this to be equal to 0, the sum, 1 plus 3 is 4, -4 is 0. So in this case, Na is 1, N is 3, and O is -2. K, I, and O. Okay. K is +1, and there's 1 of them. O is -2, but there's 4 of them. And how did I know K was 1 and O was 2? We'll go here. K is 1 right here, and O, oxygen's -2 right there. And then this has to be a 7 to be equal to, you're adding them to be equal to 0. Sometimes you might accidentally pick the factor and multiply, and that is incorrect, so you got to be careful. You have to remind yourself that the sum of the oxidation states is 0. Now this one, MgCO3. Mg is right here, I'm +2, and then there's 1 of them. Oxygen we know by now is -2. And then in order for this to be equal to 0, 2 plus 4 is 6. So Mg is 2, carbon is 4, and oxygen is -2. Now I want, once in a while, there's a difficult one where we're not sure what charge to use, and I want to show an alternative way. Let me do Mg3PO4 2. If the after the metal, the second half is on table E, and here's table E where we have polyatomic ions, and you see phosphate right here. Sometimes it's easier to separate it into the metal and then the ion from table E. And then if we look up Mg, Mg has a +2 charge. And then here we have to separate this. Oxygen we know is -2, but there's 4 of them. But the difference here is this is an ion, it's got a charge, so it's not, the sum is not equal to 0. The sum is equal to the charge. So now I have to do Because if I put an 8 here and thought it was equal to 0, if we look at P cannot be an 8. It could only be a negative 3, 3, or 5. But I know that I have to make it equal to negative 3. So negative 8 plus 5 gives me negative 3. So that's how you would do a more difficult one. But this will come up when we do redox chemistry. So I hope that helps.